Okay, now for another example where this time the expected frequencies will not all be equal. So I'm not again just referring to this scenario, which is right here. So again, the previous example in the first part of the videos was when all the assumed frequencies would be equal, but this time the expected frequencies will not be equal. So for this example, this comes straight out of the book, and the frequency of the number of games played in Baseball World Series are given in the table below. So now you're going to use a zero point 0.05 significance level to test the claim that the observed distribution fits the expected distribution based on the expected probabilities reasonably well. So again, just this one is a little strange because there's so many numbers in there, but the categories this time are 4 games were played, and in an actual World Series that happened 19 times. If 5 games were played in the World Series, that actually happened 21 times. 6 games being played happened 22 times. 7 games being played that happened 37 times. And now the expected probabilities for, say, 4 games to be played in the World Series is 2 out of 16. 5 games being played, 4 out of 16. 6 games being played, 5 out of 16. And 7 games being played, 5 out of 16. So when we just go through the steps and for a hypothesis test, the first part is the claim is that the actual proportions fit the expected or claimed proportions within some statistical significance. Step 2 just being that the opposite of that claim is that at least one of the proportions does not match the claimed proportion. That's enough to say that basically it's the opposite of that claim. And so just actually putting those into the hypotheses notation, and just always keeping the null hypothesis with the equals. So we're saying the probability for 4 games being played should be 2/16. Probability for 5 games being played being 4/16. Probability for 6 games being played 5/16, and probability for 7 games being played 5/16. And for the alternative hypothesis, at least one of those proportions should differ from the claim's value. Then step 4, just noting that our significance level is 0.05. Step 5, just also noting that we're using a goodness of fit test and using that chi-square distribution again. Now for step 6, now we can find the critical value from the chi-square table. And since notice we've got 1, 2, 3, 4 categories, then in the chi-square table, I'm looking at this column for 0.05 significance level, and then 3 for the degrees of freedom. So my critical value is 7.815, which we got right there. And now I recommend using technology again for finding the rest of the stuff as the test statistic and the p-value. Now, the Statsmantic outputs are great again, so still just using that same chi-square goodness of fit test. You can also use Google Sheets, but again, I'm going to show how to use this in a separate video. And so I went ahead and typed in some of the data already for this information, just to save time. So once I've got the categories all typed in, 4 games, 5 games, 6 games, 7 games, those frequencies that were just taken right from this table here. It's just organizing vertically rather than horizontally this time. Click Begin Analysis. And I need to go down, and again, I'm just making sure I'm doing a chi-square goodness of fit test here. And I need to type in the expected counts, and I'll be able to perform inference after that. Now, to find the expected counts for this one is a little bit strange, because since in this case, I need to, in order to find the expected frequency, each time I need to take the total sample size and multiply it by the probability for that expected category. And so the total sample size I get from counting up all these observed frequencies. And so adding up the 19, 21, 22, and 37, I get 99. And from the category of 4, the expected probability was 2/16. 5, the expected probability was 4/16, and so on. So I'm just kind of putting that together in this table. We're going to do 99 times the 2/16 to give me that 12.375. for 5 games, 99 times 4/16 to get me an expected frequency of 24.75, and so on. And of course, we wouldn't actually be playing 24.75 games for an expected frequency, but we can use decimal approximated numbers for goodness of fit tests like this. Now, again, to save time, I put all these expected frequencies typed just like that in a different tab here. This is still all the same Baseball World Series information here. And now, once I've got those expected frequencies typed in, I can just click on Perform Inference. And so I can confirm my chi-square test statistic is 7.885, and my p-value is 0.048, which the test statistic I find from going through the same process with the previous example, adding it all up, 7.885, which is also noted here, 7.885, and that p-value matches up with 0.048. All of which can tell me that since the test statistic is bigger than the critical value, since we always do a right tail test, that tells me I can do reject. And also, since the p-value is smaller than the significance level of 0.05, that can also tell me reject for step 7. And then the last step of that example is just noting that there is sufficient evidence to warrant rejection of the claim that actual numbers of games in World Series contests fit the distribution indicated by the expected proportions given. So basically, these actuals don't match an expected distribution.